function that previously with 5G you couldn't do it. And depending on the application, whether you want to be close to the device, because it may have a latency requirement, which is only can be reduced by being close to the edge. This is a physical low speed of light. Or depending if you want to aggregate many data, you may have distributed side or central side where you run a mega application that can collect data from different parts of the world. This is basically a description of the stack of 5G. Basically, you have an orchestration of how to configure the application and the network. And depending on the use case, you want to do different configuration. For instance, enhanced mobile broadband, which is the first line, you basically allocate RAN, radio access network functions, and enhanced packet core equally distributed. This is basically what is done in 2G and 3G, with the difference is that now all those functions are virtualized and can be configured. Previously, it was physically located at a specific point. When it comes to critical machine interfaces, like controlling a robot, you really need to have like milliseconds latency or 1 or 2 milliseconds. So basically, all the radio and packet core and application are basically located at the radio level, very close to the site. It's basically cases of application, industry application, where you have your own private network, for instance. And when it comes to massive type of communication, which is basically IoT, you may want to gather data from different sites and aggregate it into the application, so the distribution of virtual functions are done in a different way to secure quality of service. 3GPP is the organization who basically standardized 5G and also before 4G and 3G, where there's a study ongoing about how to enable application developers and companies that are not necessarily part of the operator domain, where how you can incorporate services that are XR specific, but also wanted to use edge computing and use the capabilities of 5G. When it comes to yellow part, this is basically part of the architecture of 5G media streaming architecture, where you can find information in the CPP. You have the 5G system, which is the gray part, which is the user equipment. You have the data network, which belongs to the operator. You have network explosion functions and policies that handle the functionality. All this is part of the standard 5G application. And what this work is trying to do is basically define a specific interfaces. For instance, you have N number of interfaces that connect to the network exposure function that can be used for services on XR. You may have in the device an XR session handler and an XR engine that do a little bit of functionality, but at the same time it's connected with an application service in the network that can help the device to do some XR processing. For instance, you may have a graphic rendering in the cloud that communicates to the device, and you have an X number of interfaces that can that being currently standardized in 5G. Here you see this is basically a document that was released in March this year. It's not necessarily the final part, it's a work in progress. So some interfaces are part of the 5G media streaming scope, some of them are part of the 5G system, and some are at this moment of this document was out of the scope. However, this can change. And basically, this allows the third-party application developer connect their solution into the 5G network. As you can see, this is a specific function use case that enable the full capability of the operator's network, where you have cloud embedded into the network, which we call it native cloud. However, there are other architecture that can deal with, let's say, the operator network plus a third-party cloud provider that can be connected to those using those interfaces. This is a work ongoing, and most important here is that there's some APIs that are going to be exposed for the application developer and write all this together. What we have done in Ericsson, it's basically experiment with 5G networks. because what we want to do is to understand how to configure the 5G system, how to enable those capabilities to a third-party developer, like an XR application developer. So for the past year, we have done some collaborations and some experiments on how to deal with edge computing, how to do edge graphic rendering, and basically have a thin device that basically just shows video. This example, for instance, is a sort of XR application. Basically, the user see what is around you, but it's a feedback from the camera to the head-mounted displays of virtual reality. So basically, you are still see what you are standing, but in some part of the area, you see the graphics that is done in a specific part of the area where you see a movie, which is a Batman versus Scarecrow. What is interesting here that there are two things to consider here. It's that the graphic rendering is done in the edge cloud, and it's mixed in the edge cloud and just send video to the device. Basically, you may have a very thin device that can deal with the XR processing. Also, we have working with enabling a XR application for factory, and for that particular case, I'm going to show a video to explain how it is.
In lean production, a factory manager makes a regular Gamba walk on the factory floor to learn how the factory performs and get ideas how to improve. With 5G connected AR glasses, Ericsson Communication Accelerator provides AR audio and video calling services that allows factory managers to immediately reach out for remote support.
Here you can find a list of contacts or the latest contacts called with the glasses. Make a call now by clicking on the phone.
Hi Isra, I noticed that the OEE is quite low. Can you please explain why?
Hi Ali, there's an unexpected delay in the shipment of the parts. We expect them to arrive tomorrow.
Okay, thanks.
Okay, so one thing about what we want to do in 5G is enable XR. So one of our customers said that they want to cut the core on XR, basically enable 5G and edge compute, which is from our perspective means that you will have thin devices and with low power consumption, which basically means you'll be able to have a 5G device in your AR glasses, and the battery will last very long as all the processing is done in the edge or in the cloud. When it comes to how Ericsson works, Ericsson basically works with a big ecosystem of XR. Basically, we, as Ericsson mobile network vendor, we collaborate with operators, 5G chip manufacturer, VR, AR devices, and we also work with XR development engine and developers studio, which is very important. And what is more important here is that we work together to understand what are things required to enable 5G, and we try continuously working on how to characterize the 5G network, which APIs to expose, and then promote that either by open source or working with a standardization organization like 3GPP. So we welcome all the developers and companies that wish to experiment with 5G to read about D15, so we can work and collaborate to make 5G and XR successful. Thank you very much, and that concludes my presentation today. Hello, can you hear me? Great, so if any question, I guess some people ask where we can test. Well, I just mentioned that we have D15 lab in Santa Clara, where basically invite companies that can experience 5G. Someone's joining. Hi.
Hi. do you have a location in Europe where it's possible to try some of your solutions?
Yeah, we have a demos areas that part for exhibition, but actually located in the headquarters, Kista, Stockholm.
Great. Is that the other demos than what you did in Santa Clara?
Yeah, I don't have it on top of my head. We normally have plenty of demo with regards to many industries, but when it comes to AR, you saw the video with AR, which is basically the one that is showcasing in the Ericsson studio, actually. But other ones we haven't released yet, as we are working with a project called Atlantis, and basically trying to do some sort of edge cloud gaming, which basically means SIM devices, basically just a video decoder in your glasses, and the rest is done, all the compute is done in the edge.
Cool. So just to inform you, we in 2 minutes we have a talk from Nokia, Leslie Shannon. So she's representing another 5G technology provider. So it's kind of interesting that we have Ericsson originating from Sweden, and then we have Nokia from the neighbor country, Finland. And both of you are keenly interested in XR. What's your perspective on how important is XR going to be for driving demand for 5G?
Well, the thing about 5G, it's not specifically for one particular use case. It's about enabling a set of services, and you can still do a lot of XR services today, and you have limitation, bandwidth, and etc. But the main limitation which you get in XR normally it's the power consumption, which 5G can help you to basically have SIM devices with low battery consumption that can last 24/7. That's the idea, but that's going to take a long time. There's some lot of work and experience we need to do in 5G to understand what to enable to the developers, how to best use that one. And so far, the experience say that it's not necessarily low latency that you need to have. It's more about reliability of the connection, which is basically a consistent bandwidth with a consistent latency, which can enable it to have SIM devices with XR and edge compute.
Yeah. So I think we have 1 minute until Leslie Shannon from Nokia will start up her session. I think there's some commonalities with what you're talking about on the technical level. I think Leslie will take a little wider look outside of what Nokia is doing. Some interesting things going on in Asia that is, yeah, I didn't know about. So please go to that next webinar that starts in about a minute.
Okay, thank you very much. You can send me questions later if you want. Bye.